Atenção, ajeitando o peito Pelé, pintou o adversário, vai marcar, atirou. Gol! Uma beleza de gol! Gol do Brasil, Pelé!
Hello everyone and welcome to Podium Cast, your sports scientist podcast. Today is my pleasure to interview Maximilian Schmaußer. He moved last year from Regensburg to the German Carnaval city, Cologne. He's a former soccer player at TV 1807 Velburg. He loves to play as well magic cards, FIFA and PlayStation, and currently he's training tennis at the university level. He's part of a scientist band at the German Sports University where he plays guitar and piano. He speaks 3 languages, and he just submitted one year-long hard work systematic review about heart rate variability and TMS. My dear Maximilian, how are you?
Well, thank you, Walter, for having me in your Podium Cast, and thank you for your introduction. I'm feeling good. I'm pretty happy that I just submitted the paper, but as you know, as a scientist, when you finish one project, the next one is already waiting. So I'm already busy again.
Nice. Now, this is a part of the process, but we are really happy that you found time for us to speak a little bit about your project. Besides our interview, we also have the pleasure to receive Marius Kruscher, a PhD candidate at Institute for Clinical Neurosciences and Medicine Psychology. Marius, how are you?
Hey, Jose. Hi. I'm good. I'm happy to be here, and I hope I can contribute a little bit to the discussion and to the understanding of the listeners. And thank you for having me. Thanks.
Nice. It's my pleasure to have you here, mate. And from the other side of the Atlantic, we also have a unique attendance of Ricardo Jr., Master Student of Physical Education and Health at the University of São Paulo. Ricardo, how are you?
Hi, Walter. I'm fine. Thank you for this opportunity to learn, and hi for Max and Marius too.
Nice. Welcome, everybody, and let's go. Okay, Max, could you tell me a little bit more about the story behind the publication entitled "The Effects of Heart Rate TMS over the left dorsolateral prefrontal cortex on stress regulation as measured by cortisol and heart rate variability"? Who had the idea about this paper, and how was the process to select the co-authors?
All right. So let's start with the history behind this paper. That's already my master thesis. And actually this paper or this project started when I went to Belgium for half a year as an internship. And I was intern at the Ghent, this city in Belgium, the Ghent Experimental Psychiatry Lab. And I was there with my supervisor, Matthias Polopoulos. He's a Spanish or Argentinian scientist, neuroscientist. And together with him, the project was already planned. I have to admit, it was not my idea. It was his. And I was happy to have the opportunity to help him in this project, conducting all the TMS stuff. And that's the story behind this paper. And I can already start to tell about the content of the paper, what we wanted to study.
Yes, I think it's a really good idea, but I want to say that maybe for our audience, all the abbreviations that we will speak, it can be a little bit complicated because it is proposed as TMS at DLPFC may induce changes of cortisol regulation at HA. So would you mind to explain to our audience what cortisol is, what TMS is, what DLPFC is, and HA is?
All right. I think I would start then, starting with the cortisol. So our human body, or like the body of all mammals, has systems, like physiological systems in the body, that are active when we are in stress. When we're in stress, we need energy. We need to be active. That developed in some thousand years or some million years ago, when we had to run away from, or like when some organism or some animal had to run away from animals, or from any other animals who wanted to kill or eat them. So we need energy. We need to be active. And then there's a system in the brain that's starting to get active, and then this system releases some hormones in our body, and cortisol is one hormone in our body that makes us active. And nowadays, when we are stressed, even if we don't have to run away from something, our body still releases cortisol in our blood. That's the cortisol.
Great.
The other thing is the HA, did you say?
Jose is probably talking about the HPA.
Sorry, HPA.
The HPA axis. Yeah, the HPA is more or less the system, the part, like the system. The HPA axis is the system that is activated, that releases the cortisol. Then it's like there's one part in our brain and one in our pituitary, that's like part of the kidney, if I'm right. And then at the end, this system releases the cortisol in our body.
I see.
So that's the first part. We need to know when you're stressed, then cortisol is released in our body. And the thing is, when we have acute stress, so if there's a stressor and we need to be active, then this cortisol increase in our body is healthy, or it's good, because we need to be active. We need to face the stressor. But at some points, we have this cortisol reaction does not stop anymore. So we always have a high cortisol level, even if the stressor, or even if we are not stressed, or there is no stressor appearance, and we still have high levels of cortisol. And then this high level of cortisol can damage other systems in our body. For example, there are negative effects on our brain, and it also can cause depression or diabetes or diseases of the heart.
Yes.
So
I understand. Thanks a lot. Yeah.
I'm in a roller coaster and I've much fun, but my arousal state is super high. Do you maybe know? I don't know if there's actually much about out there in the research, but do I then also have higher cortisol levels, for example, also in this aroused states, in the stress states, but my cognitive interpretation just simply differs and give it a different tone, a different nuance.
Yes, I would say that's also related to competition. If you go back to the sports, which is our main topic, I would say that you could also add this related to competition or stress before the competition, while you are competing, and so on.
Exactly. There is research also showing, for example, I don't know if you have a cortisol release when you're in a roller coaster. I guess yes. But there is research that shows that you have an increase in cortisol levels even if you just have no stressor, but have like a cognitive test or task you have to do, or if you have a physical task, you also have a cortisol release then as well, even if it's not a stressor, like a simple stressor as we know. So yeah, basically you have a cortisol increase when you have to be energized.
I see. I see. Yeah, coming back to abbreviations, could you tell us a little bit more about the TMS? What is TMS for those who are not aware about this?
All right, so TMS, I can say the full word or the full thing. It's called transcranial magnetic stimulation. So let's start what transcranial mean. Transcranial means that we stimulate not within, like cranial, the cranium is there, the skull, the head, let's say head, and transcranial means we're not stimulating within the head, so we not go into the brain. Transcranial means we stimulate outside the brain. So we stimulate outside our brain. So what is TMS? You can imagine TMS, it's like a little device, and this device can make a magnetic field. So it looks like it's like this big. Looks like
kind of
coil.
it looks like an 8, right?
There are some coils that look like an 8, exactly, but there are some that just look like a circle.
I see.
And in this coils or in the circles, there's a wire, and we send a current through this wire, and then the coil generates a magnetic field. That's simple physics. I'm not a physician. Physician. I don't know how to say it, but it's basically physics. So we have a magnetic field, and this magnetic field then can pass our brain. And as our brain also works with electric impulses, this magnetic field, when it comes in our brain, generates electric impulses. And so that means when we have this device here, our frontal part of the brain is activated. So if we have it here, our upper part of the brain is activated.
Yes.
And then you also mentioned the high frequency, the HF TMS. So what you can do, you can give always a simple pulse. For example, if you would hold this device over the motor part of the motor regions of our brain that are responsible for our movements, when you have it here and you have one single pulse, then our hand would like move like this, would click, and then our hand would move. But what we can do, that's like a single pulse, but we can have multiple pulses. And high frequency means we send these pulses in a very high frequency over a long time, about 10 minutes, 10, 15 minutes. Always, it sounds like this then, but brrrr.
I see.
And after this 10 or 15 minutes of high frequency pulses, this part of the brain is more active than before. And so we can test with this device, we can test, okay, let's see, we want to make one region more active, and how does this change our behavior then?
Mm-hmm.
And
Yes.
that's the TMS device.
Nice. Yeah, then I think just to close up this abbreviation for our audience, yeah, could you tell them what is DLPFC?
Of course, like the DLPFC and the dorsolateral prefrontal cortex. That sounds pretty complicated. Actually, it's just a specific part in the brain. What our listeners need to know basically is the prefrontal cortex, the prefrontal part, that just means that's a part like here in the front of our brain. And in this part of the brain, most of our executive function is. That means if we need to do like more complicated thinking, or if we want to regulate our emotions, all these functions sit in the frontal part.
Great, thanks for the explanation. I really appreciate that. Yeah, let's go a little bit to the review process. How was the review process of this paper? Was it a hard path to get published, or was well accepted by the reviewers?
It was well accepted, actually. I remember that we only had one revision, I guess, which came pretty fast. And then Matthias, the first author, and me, we had a look. And okay, I have to say that most of the parts were revised by Matthias, he did most of the job. But actually it was pretty fast, yeah. We conducted the study. I think it took us until when we had all the data until May 2019. Then we wrote the manuscript, and I think it was published in June 2020. So it was not very fast, but it was okay. Let's say it like this.
I see. I see. Yeah,
And
Ricardo. Yeah, go ahead.
I just wondered, because now we talked about the TMS basis, and we talked about the neurobiological framework and the more or less the experimental setup. And so your target region was basically the dorsolateral prefrontal cortex, and you used high frequent repetitive transcranial magnetic stimulation to activate this region.
Exactly. Yeah.
And like, what was your hope to, or more or less your hypothesis? What did you aim? What was the aim of the study, so to say?
Okay, the aim was that, like, as we pretty much know that prefrontal regions are involved in stress regulation, and involved means that if our prefrontal cortex is active, it suppresses the activity of the amygdala, a region that is responsible or is involved in the stress response. So our hypothesis was that if we activate prefrontal regions, like if we want to go deeper into the topic, it's actually not the DLPFC, it's another part, but we cannot stimulate this part specifically, so we use the DLPFC. And the idea behind this is that activating the prefrontal regions helps us to improve stress regulation, and consequently, if we are faced with a stressor, if we have a more active prefrontal brain, then the stress response should be lower.
Okay, cool.
Yeah, Ricardo, do you want to make your question?
Yes. You used only women in your sample, and my question is, why do you don't use men? And if you think that use this other population, you could be other other projects, other research questions to do.
Yeah, good question. Actually, I when I arrived in Belgium, the design or the setup was already fixed. So I had to face that we only test women, and I also asked my my supervisor why we do it like this. And like his argumentation was that, now I have to tell a little bit more. This type of stimulation is also used in depression. You also and this mixed, or this how to say, this messed up stress system, like if you have a too high cortisol increase, is one symptom in depression. And when I asked him why do we only use women, then he said because depression is more common in women than in men, and that was the argument. I don't think it's a really good argument, but okay.
I see. Yeah, actually, it's a good question, and I understand the point now.
But still, the sample size is massive, so I guess that's. I was really like, your sample size is so high. I was impressed. Like barely, like many studies just come up with a few samples. So to me, actually, it didn't matter that much if it was just females. I just saw the number and I was like, okay, that's
yeah, like 80 is really high for neuroscience, I have to say. But the thing is, the effects that we have with TMS are like, they're not that big. So to really find effects, you need to have like a high sample size.
Yeah, can I ask you on that? Because you used a high frequent repetitive TMS, and did you have a specific frequency you wanted to tackle, or like did you like, was it, did you put in some number of frequency of stimulation, or was it like an idea how much pulses per second will be
like we have, no, there is not a certain number of pulses you need to have. actually it's like this, that there are certain TMS protocols. They are already tested. Most of them are tested over the motor cortex, because then you can easily see, like the motor cortex is the easiest region of the brain to test because you have a movement of the arms or not. And over the motor cortex, the researchers, like who do this basic research, they test certain protocols, like they change their frequency, they change the number of pulses, and then they see, okay, the brain region is activated or it's inhibited, and then the other researchers just take these protocols and use it on different brain regions.
Yeah, okay, cool.
Nice. Max, I want to know, because as you may know as well, our audience here loves sport. So could you please suggest how could sports scientists profit from your publication? Meaning that how could they use the results as well, the method that you have used, more specifically to sports sciences?
Actually, there is already people doing research in with TMS or with another brain stimulation technique in sports science. Unfortunately, here there is some lack of theory. So the researchers just more or less stimulate everything they can and look if this have effects on endurance, on technique, on whatever. But there are certain findings that show, for example, that I remember one study from a former professor in Regensburg. She activated the motor cortex, and then I think it was students or basketball players, I don't know, they had to have throws, and after the stimulation they had a better, like higher accuracy in their throws. So that's one thing. Another thing is there are some theories that say that the prefrontal region, our prefrontal cortex, also regulates when we stop to do a task due to like if you are a marathon runner and you're in pain or just you're completely wasted, then our prefrontal cortex says, okay, and now you have to stop, and then you just stop. And so there might be the possibility to modulate the activity in our prefrontal cortex to overcome this effects of tiredness, for example.
Yeah, actually, I lived this when I was living in Münster. Well, I did my first marathon, and so far it's the last one. And I can say that my prefrontal cortex said, it doesn't matter what you want, it doesn't matter what you think that you can do, just stop. And yes, actually I stopped, and then I had a lot of pain. And then I said, I don't care about what I'm saying to myself, walk. And then I had to walk some kilometers, and then at the end I finished, but I fully understand this mechanism because I lived this. Dear Max, actually heading to the end, I really want to know from your own experience as a scientist, what kind of tips you could give for the future generation of sports scientists?
In terms of brain stimulation, or
in terms of everything, so something that you have done really good to bring you where you are now?
Okay, well, I have to say, and that's one point I just learned here in Cologne from Markus, and you will know what I just say, or you will have heard it already. Have a good theory. Just like everyone can do just and study on anything and just try something out and be explorative. But having a good theory in the background, working upon this is really, really helpful because it makes it a lot easier to set up a design. It makes it a lot easier to argue. And I know this because many researchers in using brain stimulation, they just stimulate everything and anything because there was a finding and there was a finding, and we know that prefrontal cortex is involved in that, and so they just stimulate everything everywhere. You can do this, but then it's not really good science. So if you really want to do good science in every field, but specifically in this field of sports science, always have a good theory, because I think even in sports science, sometimes there is a lack of theory. And that's one thing that sports science can learn, maybe from psychology, where I come from.
Yeah, nice. Yeah, guys, if you have no more questions, dear Max, Marius, and Ricardo, thanks a lot for your attendance. Have a good night and see you next week at Podium Cast.